Welcome to the deep dive. So, you're here with us today because you're trying to navigate this pretty exciting data landscape, right?
Yeah, it's a big field.
And you're specifically thinking about data engineering versus data science.
Yeah.
You actually said you felt, set and kind of stuck between those two paths.
It's a really common place to be, honestly. So many people are weighing those options.
Right. So our mission today in this deep dive is to give you a really clear comparison. We'll look at the job market, especially thinking about Europe and Italy, given your interest and, what the future might hold for these roles.
Exactly. The goal is to help you feel more confident in making a choice.
Okay, so maybe just a quick definition to start. Data engineering.
Sure, think of data engineering as building the backbone. They create and maintain these really robust systems for collecting data, storing it, processing it. They're the infrastructure folks.
The architects, the builders, got it,
Yeah.
and data science.
They're more like the insight miners, maybe. Once the data's there and usable, they dive in, analyze it, look for those valuable insights, and develop solutions based on what they find.
Okay, insight miners, I like that. Detectives, maybe?
Yeah, detectives works too. But the key thing is, while they're distinct roles, they have this, symbiotic relationship. They really depend on each other.
Okay, that makes sense. Let's unpack data engineering first then. What does a data engineer really do day to day?
Well, fundamentally, they're the ones building and maintaining the foundations. Everything data-related is built on top of their work.
So like the plumbing.
Kind of, yeah. A huge part of their job is designing and implementing data pipelines. These are the automated ways data gets moved and transformed. You hear terms like ETL and ELT.
Extract, transform, load,
Mm-hmm.
and extract, load, transform.
Exactly. ETL means you clean and shape the data before it lands in, say, a data warehouse. ELT loads the raw data first, then transforms it inside the warehouse. Different approaches for different needs.
Okay, so they're managing the whole flow and transformation process.
Precisely. And it's not just moving it, they're also heavily responsible for data quality, integrity, making sure it's, actually usable and accessible.
Accessible meaning people can get to it.
Yeah, getting the right data to the right people securely. This involves cleaning data, validating it, setting up rules that's data governance. It's like setting the traffic laws for data.
Sounds like you need some serious tech chops for that. What kind of tools are we talking about?
Oh, absolutely. Core skills. Definitely strong programming. Python and SQL are essential. Often Java or Scala too, especially for larger systems.
Okay. Python, SQL, Java, Scala. What else?
Database knowledge is crucial. Both the traditional relational databases and increasingly NoSQL databases for more flexible data types.
Right, handling all sorts of data.
Yep. And because so much is in the cloud now, expertise in platforms like AWS, Azure, GCP is pretty much a must-have.
Makes sense. Cloud is everywhere.
It really is. Then you've got big data technologies, think Hadoop, Spark, Kafka for handling truly massive data sets. And data warehousing solutions like Snowflake, Redshift, BigQuery are key for analytics.
Wow, okay. Anything else?
One more big piece is orchestrating all these pipelines. Tools like Apache Airflow help manage these complex workflows, making sure everything runs in the right order reliably.
Like a conductor for the data orchestra.
Ha, exactly. That's a great way to put it.
So if I'm hearing this right, the core idea is data engineers are almost like specialized software engineers, but laser focused on the data infrastructure, right? Making it scalable, reliable.
That's spot on. They build that foundation. Honestly, without good data engineering, data scientists would really struggle just to get the clean, accessible data they need to even start their work.
Okay, that provides a really clear picture. Now let's pivot. Data science. What's their main goal?
Their main goal is taking all that well-engineered data and actually extracting the value from it, finding insights, solving business problems.
How do they do that?
They use a whole range of methods. Statistical modeling, machine learning algorithms, basically techniques to find patterns, make predictions, and ultimately help guide business strategy.
So they're translating data into actual business actions. What's their day look like?
Well, a fair bit of it is still cleaning and preparing data even after the engineers have done their part, getting it just right for analysis.
Right, the final prep work.
Exactly. Then comes the really interesting stuff, developing and implementing those statistical models or machine learning algorithms. And increasingly that involves things like deep learning or NLP, natural language processing.
Working with text data and things like that.
Yep. Understanding language, sentiment. And it's not just about the fancy algorithms either. A huge part is communication. They
Yes.
need to create really clear data visualizations using tools like Tableau or Power BI to show what they've found, and then they have to explain those findings, those recommendations to all sorts of audiences.
Ah, so technical people and maybe business folks who aren't deep in the data weeds.
Absolutely. That means collaborating closely with business stakeholders to really grasp the problems they're trying to solve. It's a mix of tech skills and softer skills.
So what are the essential skills then, beyond the modeling?
Strong programming is still key, especially Python and R are very popular. A really solid understanding of statistics and machine learning concepts is fundamental.
You mentioned deep learning and NLP are becoming more important.
Increasingly valuable, yes. Then proficiency with those visualization tools, strong analytical and problem-solving abilities are a given. And critically, that business acumen, understanding the business context.
Okay, so the insight here feels like data scientists or maybe statistical storytellers. They blend the tech programming, stats, ML with communication and business sense to bridge data and decisions.
That's a perfect way to phrase it. They have to find the story in the data and tell it effectively so people can act on it.
It's definitely clear they're distinct roles, but you said earlier they're connected. How do they actually, work together day to day?
Oh, collaboration is absolutely vital. I mean, data engineers build and maintain the very infrastructure the data scientists rely on constantly.
So the scientists depend on the engineers.
Totally. But it's often a feedback loop. Data scientists will figure out, hey, I need the data structured this way, or I need access to this new data source, and they feed that back to the engineers.
Ah, so the scientist needs help shape what the engineers build or optimize.
Exactly. Maybe data scientist finds a new transformation could really improve their model. They work with an engineer to get that built into the pipeline. It's very back and forth.
So really two sides of the same coin. You can't have effective data science without solid engineering, and the engineering is often driven by the analytical needs.
Precisely. They're intrinsically linked. You need both for a strong data ecosystem in any company. The quality of the science depends on the engineering, and the engineering priorities are shaped by the science.
Okay, that clarifies the relationship. Now let's get to a really crucial point for, career planning. The job market. What does it look like out there globally, but also specifically thinking about Europe and Italy?
Globally, the demand for both roles has just exploded. There's so much data, and companies desperately need people who can manage it and get value from it.
Any specific number, your projections?
Well, the U.S. Bureau of Labor Statistics, for instance, projects data science roles to grow much faster than the average job. But data engineering is also seeing really robust growth as companies just keep building out their data capabilities. It's strong across the board.
That's definitely encouraging. What about closer to home for someone potentially in Europe or Italy?
The picture is very similar in Europe. It's a vibrant, expanding market for both. Digital transformation is a huge driver everywhere.
So companies are investing heavily in data.
Absolutely. This means strong demand for data engineers, especially those with cloud skills, and at the same time, a big need for data scientists to actually analyze all that data and provide business insights.
Are there specific hubs or industries?
Yeah, major tech hubs like London, Paris, Berlin, and definitely Milan are hotspots. And you see demand across finance, healthcare, retail, e-commerce, manufacturing. It's widespread.
And Italy specifically?
Italy's tech market is growing with real investment in big data and AI. So yes, that's creating significant opportunities for both data engineers and data scientists there too.
Okay, so good prospects generally. Is one role maybe in higher demand right now? Any difference?
That's an interesting question. There's some evidence, some reports suggesting maybe a slightly higher current demand for data engineers right now.
Why would that be?
It kind of makes sense, right? You need to build the foundation, the infrastructure, before you can do the really advanced analytics or deploy complex AI models. So as companies are scaling up, that foundational need is immediate and huge. Plus, the shift to the cloud requires engineers.
So maybe more open positions for engineers at the moment.
Potentially, yeah. Some reports indicate that. But, and this is crucial, data scientists are still incredibly essential and highly sought after. You absolutely need them to unlock the actual value. So while maybe the volume tips slightly towards engineering right now, both are in very strong demand.
Okay, that's helpful nuance. And what about AI? Everyone's talking about the AI revolution. How's that changing things?
Oh, profoundly. For both roles. Data engineers are now building the infrastructure needed specifically for AI and ML development, training, deployment. This whole area called MLOps is booming.
Machine learning operations?
Exactly. Managing the life cycle of ML models. And data scientists, They're using more AI-powered tools themselves, and they're the ones integrating AI models into production, into business processes.
So AI is creating more work, not less.
For skilled people, yes. We're also seeing these hybrid roles emerge, like machine learning engineer or AI engineer, that blend skills from both sides. The big takeaway is that AI skills are a massive plus, whether you lean engineer or scientist. Demand for AI-savvy pros is just skyrocketing.
Okay, so summing up the market. Strong demand globally and in Europe, Italy for both. Maybe a slight edge for engineers right now due to infrastructure needs, but DS is critical, and AI is a huge driver for future growth in both.
That's a really good summary.
All right, let's talk rewards. What does this demand mean for salary potential? How do they compare?
Both fields offer really attractive, competitive salaries. There's an argument that with the current high demand, data engineers might be seeing slightly faster salary growth in some places right now.
But both start well.
Oh yeah, entry-level salaries are strong for both, and the potential for increase with experience is significant. Just as a benchmark, in the US for 2024, the median for data scientists was around, $112,590. Data engineers command really impressive salaries too.
That's definitely motivating. How does that translate to Europe and Italy?
Similar story. Competitive salaries across the UK and Europe, including Italy, reflecting that high demand. Of course, the exact numbers vary a lot based on experience, your specific location, the industry.
Big city versus smaller town, finance versus retail.
Exactly. Those tech hubs like London or Milan will generally offer higher compensation. In Italy specifically, the average ranges for engineers and scientists are actually quite comparable.
About the same.
Pretty close, yeah, with really good potential for growth based on experience and specialization. Entry level might be around 40,000 maybe. Senior roles can easily get up to 90,000 or more for scientists. Engineers are in a similar range, maybe even higher potential if they have sought-after skills like cloud or big data expertise.
We actually looked at some estimated averages for Italy for 2025, converted to USD for comparison. It seems like for junior roles, 0 to 2 years, both are roughly in the 50K to 67K range.
Okay, yeah, that sounds about right.
Mid-level, 2, 3, 5 years jumps to maybe 67K to $100 for both.
Significant increase.
And then senior, 5+ years, looking at $100K up to potentially 150K plus for both engineers and scientists.
Yeah, see? Very comparable earning potential at those senior levels. The financial rewards are strong whichever path you take.
Okay, so pay is good and fairly similar, especially as you get more senior. What about career progression? Where can these roles lead?
For data engineers, you often see moves to senior data engineer, then maybe data architect, designing the overall data landscape, or into management, leading engineering teams.
Makes sense. And for data scientists?
Similar progression in seniority, senior data scientist, lead data scientist, data science manager, or they might choose to specialize deeply in areas like machine learning or AI research and application.
And you mentioned those hybrid roles earlier.
Exactly. There's increasing opportunity to move between roles or into those blended positions like machine learning engineer or maybe analytics engineer, which bridges data engineering and analytics more directly.
So your path isn't totally fixed once you start.
Not at all. It really depends on your interests, the skills you build, what your company needs. Engineering might lead towards more strategic infrastructure roles, while science might lead more towards influencing business strategy directly with insights. Both great paths.
So strong money, clear advancement paths, flexibility. Lots to like. Now, the big question for you, our listener, feeling uchien akote, how do you actually make the right choice for you?
This really comes down to self-reflection. You've got to think about what genuinely interests you more.
Like, do you get excited by the idea of designing and building the systems, the plumbing, the infrastructure, or is it the puzzle of the data itself, finding the patterns, telling the story?
Exactly. Are you drawn to the elegance of well-built, efficient systems that might lean you towards engineering? Or are you more energized by the aha moment of discovery within the data, communicating that insight? That sounds more like data science.
And it's about aptitude too, isn't it? Are you more comfortable and engaged with, say, core coding infrastructure, maybe even some DevOps principles, which seemed key for data engineering?
Right. That software engineer mindset is really strong in data engineering.
Or are you more drawn to the statistical thinking, the math behind the models, the algorithms, and also that crucial business understanding side of data science?
It's about where your natural inclinations lie. And think about how you like to use your analytical skills. Engineers analyze system performance, data flow, scalability.
Analyzing the infrastructure itself.
Right. Whereas data scientists analyze the data sets to find patterns, build models, answer business questions. It's a different focus for that analytical drive.
You also need to think long term, right? Where do you see yourself in 5, 10 years?
Definitely. Do you imagine leading technical teams, shaping how a company manages its data foundation? That sounds like an engineering path. Or do you see yourself influencing business strategy more directly with insights, maybe specializing in cutting-edge AI? That leans science. Or maybe that hybrid ML engineer role feels like the sweet spot.
So the key takeaway here really isn't about just chasing demand figures. It's about finding the role that aligns with your interests, your skills, what you find fulfilling, and your long-term goals.
Absolutely. That's the path that leads to sustained success and, frankly, just being happier in your job. Focus on what engages you.
Okay, so let's say someone's done that thinking, and they're starting to lean one way or the other. What are some concrete first steps they can take? How do they get started?
First off, dive into online learning. There are so many amazing resources now. Coursera, DataCamp, Udemy, Microsoft Learn, loads of great platforms.
What should they focus on?
If you're leaning towards data engineering, look for courses on Python, SQL, definitely cloud platforms. Pick one like AWS, Azure, or GCP to start, and data warehousing concepts.
And for data science?
Again, Python is key, maybe R as well. Focus on statistics, core machine learning algorithms, and data visualization tools and techniques.
But just taking courses isn't enough, is it? You need to actually do stuff.
Oh, 100%. Building a portfolio is absolutely critical. For aspiring engineers, that could mean building an automated data pipeline, maybe using Airflow, or setting up a small data warehouse in the cloud. Show you can build things.
And for scientists?
Projects. Analyze some public data sets. Build a predictive model. Create some cool interactive visualizations. Show you can work with data and extract insights. Contributing to open source projects is also a fantastic way to learn and get noticed in either field.
What about connecting with people? Networking?
Super important. Engage with online communities. Reddit has active subreddits like R Data Engineering and R Data Science. Check out the Microsoft Fabric community. Be active on LinkedIn.
Reach out to people doing the jobs you want.
Yeah, respectfully, of course. Ask for informational interviews. And try to attend virtual or local meetups and conferences if you can. Networking really helps.
Any value in certifications?
They can definitely help, especially early on or when targeting specific platforms. For engineering, look at the cloud provider certs AWS Certified Data Engineer, Azure Data Engineer Associate, Google Cloud Professional Data Engineer.
And for science?
Certs like the Microsoft Certified, Azure Data Scientist Associate, or maybe the TensorFlow Developer Certificate if you're into deep learning can add weight to your profile.
Okay, so lots of really practical, actionable steps someone can take right now.
Exactly. Just start learning, start building, start connecting. That's how you build momentum.
So wrapping this up, it feels really clear that both data engineering and data science are vital, they're growing, they offer great careers.
Absolutely. They're both crucial.
Data engineering, building and maintaining that essential data infrastructure. Data science, analyzing the data, living within it to find those key insights.
Couldn't have said it better myself. Two critical functions.
And the better choice. As we've hammered home, it's really personal. It depends on your interests, your strengths, what problems you find exciting.
Exactly. There isn't a single right answer for everyone.
But the good news is the demand for skilled data professionals isn't going away. So if you invest in the skills, follow your interests, whether it's engineering or science, you're setting yourself up for a really impactful and successful career.
Which brings us maybe to a final thought for you to ponder. As you think about these two paths, ask yourself, which part of the data journey truly excites you more? Is it the creation, the management, the structuring of the data itself, making sure it's solid, reliable, accessible? Or is it the exploration, the interpretation, the unlocking of meaning hidden within that data to drive decisions?
Building the foundation versus exploring what's built upon it.
Yeah. Thinking about where your passion really lies in that life cycle, that's probably a great starting point for figuring out your next move.